So we start with the presentation. Welcome to webinar. Today I want to introduce the new VISOR release, the release 122. So internally we talked a lot about the VISOR robotic release, but yeah, this is a main point, but not the only point. In the release we have some other new really interesting function for you. The first is the password protection for all VISOR devices. Then we have really interesting upgrades for the VISOR code reader. I will give you an introduction in the VISOR Robotic. I want to show you in detail the function, the difference between object and all round, to make it for you clear that you can communicate it to the customer when and why to use the VISOR Robotic. I give you an overview about the types, that you know which hardware and which software devices are available. And as a special interface for the VISOR Robotic, I want to talk a bit about the robotic UR cap in general. So now it's in it's the 16th of February. Normally we make our webinar on the first Friday in the month. So we see that the next webinar will be in 2 weeks. And for that we prepare some more detailed topics on the robotic UR cap especially. Today an overview, and in the next webinar you get more detailed information. Okay. The password protection means that all VISORs are now able to protect the job sets with a password. The experienced VISOR users know you can protect your sense of find. This protection is more like a PC software protection. You protect the access to the device, but not the device itself. That means when you change your laptop or you install the software again, the password protection is switched off. With the new password protection, we protect the job set. That means independent from which PC you want to connect to the VISOR, you need to enter the password. The use case is, the first one is protection of intellectual property, or the second one is to protect against misuse or access from people which are not allowed to access. So you can make your process more reliable, and you can make it more safe. The boundary conditions to use the password protection is the password protection refers to a job set, not to the VISOR itself or the PC. When the password is lost, there is no way to reconstruct the password or view the job set, but because we just protect the job set and not the VISOR and not the PC, it is not necessary to change the VISOR if you lost the password. You can handle it with a firmware update, for example, or you can manually delete the job sets from the VISOR. That means when the customer lost his password, he can easily do a firmware update, and the VISOR is going back to factory settings, so without any job set, and you can use it again. How can you use the password protection? When you open a device, independent which device, you can go to File, Protect Job Set in the menu bar. You can define your password in the text field, and you have below the text field additional information. For example, some information about your passwords, something like a password reminder. You can type in a phone number and the name of a responsible person who can unlock the device, whatever you want. You have a space of 1,000 signs to enter it, so that the customer can customize his password protection on his needs. When the VISOR is password protected, we show it in the sense of find. We have the status point, I will call it, and when the VISOR is password protected, we have this small key in here. So that means you need to enter a password to open the sensor config and if there is no small key, you can open it directly. Okay, is it now better? Okay, I go one for a back, just to make it more clear. You find it in File, Protect Job Set. You can enter the password and you have the additional information field below. And in Sensor Find, you see with the small key icon if the visor is protected or if it is not protected. The code reader get the advanced code reader get an upgrade. The advanced code reader is extended by the OCR detector. This extension is available for V10 and V20 in all types. And this extension, especially with VGA resolution, we have now a low-cost OCR device in the VISOR portfolio for the first time. How can you see this change? When you go to, for example, to the simulation modus with the new 22 software, you open a code reader in advance, so it's independent, or if you use V10 or V20, and you go to the detector list, you see the text, the OCR detector, with all his functions. You can read the text in the image, and you have all interface functions and so on. The second upgrade for the VISOR code reader is for the standard device, for the standard type. The VISOR code reader standard is extended by a shutter variation function to make it easier for us, for you, and for the customer. We extend all standard devices with this feature. But we see the main market or the main use for code reading application makes this extension makes the VISOR code reader more powerful in reading codes when the object brightness is varying. That means you can increase the reading ratio and for that a higher machine availability. The shutter variation is the basis function, is the repeat mode. You get below the option to activate with the tick the shutter variation. For example, in this screenshot, I activated for 3 images the repeat mode. So I have the option for every repeat to give a special factor to vary the brightness of the image. For example, we start with a shutter setting of 2 milliseconds. This is the value from your job set. Then I give a factor of 0.75. It means 1.5 milliseconds, and 0.5 it means 1 milliseconds. And the result you see on the right side, the first and the second image are much too bright. You cannot read the code. And with the third image, you read the code. And with this image, all data are sent out, and the image counter and archiving is started. Okay, let's go to the VISOR Robotic. The VISOR Robotic combines the well-known methods and functions of the VISOR family and extends the VISOR object with the robotic calibration methods. With these extensions, the VISOR Robotic will be the expert for robotic applications in the VISOR family. When we look at the VISOR Robotic, it joins somewhere in between the VISOR Object Advanced and the VISOR All-Round Professional. This is reflected in function and also in the price structure. That means when we look on the right or in the middle, we have our VISOR Robotic. When we look on the right side, we have the VISOR All-Round Professional. The VISOR Robotics don't have the ID function. That means you have not barcode and not data matrix code and no OCR, and you have no multi-shot. When you look on the left side to the VISOR object, the VISOR Robotic is extended compared to the VISOR object with the robotic calibration method, calibration plate robotic. We introduced the telegrams for the calibration of your VISOR device without the VISOR PC software. You are able to validate the VISOR robotic doing the process automatically. You can set the fiducials and you can read and set the calibration parameter. Also, the gripping space recheck is available in the VISOR robotic. In detail, we have two calibration methods. The first method is the calibration plate robotic. This is an easy, fast and accurate calibration method for the VISOR. This method is usable in many applications. I will say to calibrate with some defined calibration pattern is like a standard way to calibrate. With the 4 different calibration plates, we have the option to calibrate the VISOR up to field of use of 500 millimeters. And we offer the calibration plate as a PDF printout file on the installation or as a stable aluminum composite material plate. Additionally to the calibration plate robotic, we offer the point pair list compared to the calibration plate method. We have the option of a free selection of the calibration object. We have almost no restriction in the field of view. You have the option to calibrate it absolutely automatically from your robot out, and you can also validate this calibration method during your process. The next special function is the gripping free space check. With the gray background, I want to show you a default behavior. For example, the first scene is we have some coins in our field of view and no coin is able to be picked from the robot. So I have a not okay signal. This is totally clear. But when I look at the second scene, I have one coin which is on the right side, which is free. But with the default behavior, I cannot define specially which coin is picked. It can be that the VISOR find the free coin, or it can also be that the VISOR find one of these two coins which are laying close together. With the new gripping free space check, I have the option with the logical expression to define which coin is found by the VISOR and which coordinates are sent out. That means you define your contour alignment with the gripping free space check. You define a rule, what means a free space. In my case, I defined a grayscale detector and I say around my object is not allowed to have another object. And now I have the option to send this value out by the payload, and the value is called new in the new VISOR version with gripping space. The function set offset is available also for the VISOR robotic. There is one change compared to the 1.19 version. I show it on the next slide. In the old version, we had 4 options to set up the set offset depending on the orientation of the coordinate system of your robot. But typically for the customer, it is not clear how the orientation of the robot coordinate system is exactly. So for the application, it's not really important to know this. For this, we decide to make a change to make it more easier for the customer to use it. We reduce the cases to 2 possibilities, and we look now the situation depending on the VISOR to your object. The first situation is you have a calibration plate, for example, on your conveyor belt, and your object is higher than your calibration plate. That means the distance to the VISOR becomes smaller. That means you have a negative set offset. So the distance to the VISOR is smaller minus set. The second case is the distance to the VISOR is bigger. For example, you have a tray and you place a calibration plate on the edges of the tray and your object is inside the tray. That means the distance to the VISOR is bigger, so you have a positive set offset. So with these two situations, you can easily see it from outside without any knowing about your robotic coordinate system. You can easily say minus smaller distance plus bigger distance. In which applications we see in use for the customer? The first use is the calibration cannot be placed exactly at the same level as the working level is. Look at these two pictures. These are two typical situations which you have in the field. Or another option is that you need to handle objects with a different height. For example, today you produce an object with 50 millimeter height, tomorrow with 80 millimeter height. That means you need to change, for example, your calibration with another system. With the VISOR, you easily change the set offset value and you can work with the same calibration. That means you are more flexible and it's more easy to use for the customer. And this function, set offset, is a function which is unique for vision systems in this way. The next special function is the result offset function. Here one small example. I want to detect this mounting bracket with the circle with the holes, and I want to clip it out with a vacuum clipper. That means typical with a contour detector, it's easily to detect. The VISOR calculates the result point in the center of the green box. When I look in the center of the green box, there is a big hole and I have no option to pick it out with my vacuum clipper. When I now activate the result offset function, I have the option to define by click and move the result point to any point in the image I want to grip my part. For example, in my case, in the middle of this bracket. And I think now you can imagine the vacuum clipper can pick up the part at this position without any problems. The next use of this function is, for example, to adjust the position during the process without changing the robot program. For example, when you have small changes to something, made a mounting or something changed in the machine, you can adjust easily the gripping position on your part without changing anything at your robot program, so without any knowledge about your robot. The next important point, when we have calibrated our VISOR and detected the position of the part really reliable and precise, we need to send out this information to a next to controller, in this case mostly to a robot system. The VISOR Robotic has the known interfaces, for example with Ethernet, the TCP/IP protocol, the Ethernet IP protocol, and the Profinet protocol. Additionally is also the serial interface available, for example, when you want to communicate with the Profibus adapter or something like this. This is also possible. And which function we can handle about the interfaces? We can calibrate the VISOR. We can validate the calibration of the VISOR. We have access to all available data of the VISOR. We have the possibility to adjust the settings of the VISOR. For example, we can adjust the set offset value over the interface, and we have the option to visualize the images and the results of the VISOR. Especially new requests for this release are these 5 in overview: the add world point request, the calibration plate request, the set fiducial request, and the set and get parameter request. That means in detail with the add world point request, this request is used for the calibration plate robotics and the point pair list. In the future we will replace the function add point in midterm, but don't worry, in this release it is available, so customer who used it before and make an update or order a new device and use the add point function, it is available. But future orientated, we look or we prepare this new add world point request also for processing the set values. The request for the calibration plate is necessary to define the internal and the external parameters. So with the internal parameters we capture an image from the plate, and the external parameters we can set a fiducial. We have also a request to set only the fiducials. This is the set fiducial request. For example, when you need to handle some conveyor application or you only want to calibrate the world points. And 2 really interesting requests for integration in robot systems is the get calibration parameter and the set calibration parameter request. Here you have two options to read out the status of your calibration, the method which is selected, the focal length, the calibration parameter. You can set the set offset value. For example, when you have a recipe function in your HMI, this is the application I explained before. You have a different height of your object and you want to make a totally automatic switch over between these two objects. You can handle it with this interface function. Okay, the available variants are all monochrome devices. So we have V10 and V20 with the internal red, white and infrared with 6, 12 and 25 millimeters. And we offer also both C-mount types. So it depends on your C-mount length. We can offer a focal length from 8 to 75 millimeters. And to extend the range, the VISOR Robotic is also available as a color type. This is a unique position as a vision sensor, and this is helpful in all applications where the color is corrected or helps making the application more stable. For that I prepared a small example. We have a blue conveyor belt with a dark part on it. When we look the monochrome way, we have a dark object for maybe a dark gray background. I think this is not impossible to solve it with the VISOR, but when we can offer the color function, the new color function, for example, color distance, we can make the contrast of the image much more higher, and with this much more higher contrast, we can solve this application much more reliable. We can have more options. For example, on the right side, I can imagine that it is possible to detect it with the block detector or the contour detector. On the left side, it is possible with the contour detector. So you have more options to solve this application, which makes it typically more reliable. As a special or additional function for the VISOR Robotic, we decided to offer a VISOR Robotic UR cap. In general, this is an interface of the VISOR to all robots, to all robot types from Universal Robot. That means Universal Robots offers a partner program. It's called UR+, and this gives us the option to integrate our device directly in the UI interface. The UR cap, you can see it like an app for an UR robot as you know it from your private mobile. That means when you have installed the UR cap on your UR robot, you don't need an extra software. Our VISOR is directly in the UR interface, in the UR user interface. To get a status as a UR cap, we need to be certified by UR. So we send the software and the device and the manuals to Denmark. They make a lot of tests, and since we complete this test, we are officially certified and an official partner of UR. All these certified products are also shown in the UR Plus showroom. I added the link to this presentation. If you are interested in, you can look there at the presentation. I think this is really interesting for SensorPart, that our product is not only on the SensorPart homepage, so now we are also on the UR showroom homepage. What does it mean in detail? The UR cap provides all functions which are needed to let the VISOR communicate with the Universal Robot. The UR cap is available free of charge as download file. We communicate with the interface Ethernet TCP/IP. As you know, this is a standard interface of the VISOR family, so also of the VISOR Robotic, and this is also a default interface of the UR robot. That means no additional costs. You don't need additional accessories like a USB to Ethernet adapter or something like this. Just plug it in and work. We offer for the UR cap predefined configurations for the VISOR. We can automatically generate program procedures to make it more easy to use for the customer. When this automatically generated programs don't work in an application, for example, make some more complex applications, we added some advanced functionality. That means also customer which have more complicated or more complex application can use the URCAP 80%, which is easy to connect to have a live image, and make 20% of the application with this advanced functionality. The URCAP is compatible with all devices of the VISOR Robotic and the VISOR All-Round Professional. That means the hardware is V10, V20 and V20 color available, but we don't support the object, the code reader, the color and the solar. Okay, just for you maybe as an overview, what is inside the VISOR Robotic. On the left side you see this is a screen capture out of the UR showroom. I think for when you look after the webinar to the webpage to see how the VISOR Robotic is presented on the webpage. Additionally, for customer which want to start with the VISOR and UR robot, we offer some starter kits to get the destination even faster with the VISOR. We offer the starter kits. We have 3 different types of the starter kits, but each kit includes a calibration plate, the cables you need, and the mounting brackets you need. And the kits are a little bit different. I show you the content of the kits. Important to know for you is each starter kit is compatible with the robot types UR3, UR5 and UR10. So UR only offers these 3 types of robots, so you can have each kit for each robot. Just as a background information, a starter kit is a combination of individual components. We want to offer the customers an easy entry into the VISOR world. When the customer orders a starter kit, which starter kit he ordered doesn't matter. He can directly start. He has everything he needs to start with a robot and a VISOR. It is still possible to develop and offer applications individually, as you know it from other projects. The first type of the starter kit is, I would call it maybe a low-cost entry. It's a V10 robotic device. It's red light, 12mm lens. We have the cables inside, the calibration plate, and the mounting bracket. And these 5 components are all combined in this article number 933-01003. So customer who don't know exactly what he needs, go to our homepage or call you by phone. Oh, I want to start. What did I need exactly? You can offer this starter kit, for example, and the customer can start directly to develop what he needs exactly. May he need a higher resolution. For that we can offer the standard package, I will call it, with a V20 robotic device. Additionally, we have the polarizer filter included to get much more better on shiny plastic surfaces. You see now we have 8 components which are in one kit. And when we go to the third kit, for example the laboratory kit or extensive accessory kit for laboratory places or high distances, we have a C-mount device with external illumination, with a lens, with a housing for the lens, with the red light filter, all combined in the third starter kit number. Okay, so far from my side today. Are there any questions about the topic?